Ha! Back again we are. 8-3, subtracting polynomials. This is similar, but just a tad different. We're subtracting instead of adding. So we can subtract polynomials when we have like terms again. So I've got two examples here. I've got a trinomial with a binomial, and then a trinomial with a polynomial. So this is the same. I just changed as 8-2. I just changed these to subtract instead of add. And so same idea, we're going to only be able to subtract like terms in this case from one polynomial to another. So again, I look at this, I know that my only like terms from this binomial, or this polynomial is my 9x and my negative 7x. So those are the only two I'm going to use subtraction on. Everything else, I'm just going to write down if it's in the first part. There's one slight adjustment with this second one. So really this x to the third doesn't subtract anything, so it's just going to be x to the third. This 4x, or negative 4x squared, doesn't subtract anything, so this just becomes negative 4x to the second. All right, then I get to my two like terms here. I've got 9x and negative 7x. So all I do is take my coefficients like I do with addition, except for I'm going to subtract. So it's going to be 9 minus a negative 7. And whenever you have minus a negative, that becomes adding. So this will be 9 plus 7 here. And so that becomes 16. So plus 16x. And that takes care of those two like terms in this case. And then my last term is my 5. This one I have to be careful with because I have to remember about the subtraction. There's really 0 or no constant over here, so it's really 0 minus 5. So again, it's really 0 minus 5 because there is no constant over here, so we use 0 for that. Again, minus a positive 5. When you minus a positive, it just becomes a negative. Okay, so you got to be careful with that when you take care of that last term. And that becomes your new polynomial. Right, this next one here, again, we're just going to work biggest to smallest. We've got a bunch of like terms here. I'm just going to go with my highest exponent, which that's right here, this negative 5x to the third. But there's no x to the third in this case. So I'm just going to take care of that. So there's 0, again, there's 0x to the thirds over here. So it'd be 0 minus a negative 5. Remember, minus a negative becomes positive, and so I actually get 5, and then this is x to the third term. So that changes that to a positive there. Then I can go to my x to the seconds. I've got my coefficients. I'm going to go negative 8 minus positive 2. Well, negative 8 minus 2 gives me negative 10. So that gives me negative 10x to the second. And that takes care of those two like terms. Then I go to my next like terms. I've got 3x and I've got x. So I'm going to go 3, again, minus, if it's x, there's really a 1 in front of here. Just remember that. So it's 3 minus 1. 3 minus 1 is 2. So I go plus 2x in that case. Those go away. And I've got one last like terms to combine. I've got my constants. So I've got 6 and negative 7. So we're going 6 minus a negative 7. And minus a negative becomes positive. So this will be 6 plus 7, which will give me 13. So I go plus 13 here. So obviously, you guys should be able to do this a lot quicker on your own. I kind of broke it down to kind of show you, remember, you're going to combine like terms, and then remember whenever you have minus and negative, it becomes a positive. And then don't forget, if you've got a term in the second polynomial that does not have a like term, like we had over here, this 5 did not have a like term with the first one, then that minus changes the sign in there. It's like 0 minus that, okay? All right, last question. It asks us, are polynomials closed under subtraction? So again, remember, closed just refers to if I'm subtracting two polynomials, do I get another polynomial out? And in this case, that is absolutely true. I got polynomials in both those cases, and it'll happen every single time. So this is yes, for sure, they are closed. All right, this has been your math moment with your mummy. Bye.